much. And hello, everybody. As mentioned, my name is Louis, and I'm from Holo-Light. And this panel will be about Holo-Stylus. It's a new product, and the whole topic will be about interaction. Interaction in MR, which means AR, VR, and MR. Let me first introduce our company to you, because I don't think that maybe not all of you might have heard of Holo-Light so far. We are basically focused on AR and MR solutions. So we are a software, but also a hardware development company. We have a strong industrial focus, so we work with industrial clients, and we are founded in 2015 in Austria and Germany. So our headquarters is in Munich, in the south of Germany. And there we work a lot in the last 2 years on projects with industrial clients, OEMs, service providers. And within about more than 30 projects that we did, mainly on head-mounted displays like a Microsoft HoloLens, we experienced that one key component in interacting in AR and MR is definitely the interaction. So as you might have recognized over the last years, and also here at the show, there are several ways of interaction. There is thinking about a HoloLens, the gestures like that air tap. There is, oh, excuse me. Now it's fine. There is controllers in VR which you can use to interact. So it's not only using hands. It's really using some stuff which is maybe a bit disturbing. It's also lip motion, obviously, any kind of clicker, gloves to interact. And there is also obviously the gaze. Most of you have heard the eye tracking panel before. But what all of them have in common is basically that they are all kind of different. So there's not a cross-platform approach like the mouse, which we know from the 2D computing area. And what else? They are not intuitive. So if you use a gesture, maybe most of you have, when you tried a HoloLens the first time and you've tried to do the air tap, it didn't work. So it's not that easy to do, and people have to learn it. And these are a bit things which we would like to solve. The most important issue is that we experienced, and that is a big topic in some use cases, is what we mentioned and what we recognized is accuracy. So if you really want to interact with a virtual object, and you need to be precise, and that's a big point, especially in industrial use cases, you need to be accurate and precise. And this is a very big issue and a problem so far. And that's why we at Holo-Light developed something which we call Holo-Stylus. Holo-Stylus is a unique input device for head-mounted displays. So with Holo-Stylus, you are able to interact very precisely with virtual content. I'd like to show you first a video so that you can get a better feeling of how this could look like. So as you could see in the movie or in the video already, there are use cases where you can use it. It's design, but it's also something else. I will come to the use case topic a bit later, but before that, let's just have a quick look on how this whole thing looks like. Let's have a look on the specs. So besides the Holo-Stylus itself, we use our own tracking unit. And this tracking unit is exchangeable and it includes 5 cameras with infrared tracking. So basically, you put it, for example, on a head-mounted display, and then you can use it to track the pen. The active volume, meaning the area in which you can use the pen, is 60 centimeters to 80 centimeters. So it's basically the whole area in which you can use your hands. So within this area, you can use the stylus. The accuracy which we would like to provide and which we will provide for the dev kit, which we will deliver, is 1 millimeter. So we reach a sub-millimeter precision, which has never existed before. You can try our prototype over at booth 500 if you want. There you will recognize that we have a prototype with us, which is currently around 3 millimeter precision. Until we launch the dev kit, we will go down, as this needs to be taught a bit. One thing which is unique and has never been done before regarding a tracking system is that we used basically machine learning to teach and to train the pen in a way that you reach this level of accuracy. This has never been done before and is therefore unique, and this is the only method which we can use to generate this level of accuracy. All devices that you have, so the pen itself, the tracking unit, and for example, a Microsoft HoloLens, if you use it with this device, they are connected via Bluetooth. But the Bluetooth connection enables also that you can use it with other devices. So it can be other smart glasses, but it can also be a normal laptop. This way, it makes it possible to really enable that cross-platform approach. So that you no longer in the future have to switch between VR controllers by using your Vive, then you switch over to gestures by using your HoloLens. Next time you switch to eye tracking. So people really have it very simple to interact with that content. We have a micro USB charging cable, so basically all those devices are charged. The battery life is higher than most smart glasses, so you should use it for the whole time. If you stop by, do not wonder if there are wires or something. It's basically now for the whole day, so there's a chance we have to charge it. And now I would like that you know a bit more about the specs. Let's just have a look on the setup. Here you can see one of our clients at a trade fair around a month ago. So basically you can see how we have an extra mount for a HoloLens. Here we place the tracking unit on it, and basically then there you go. You just interact, and this way you can really interact with the virtual content. I don't want to stop by just showing you a marketing video. Let's just have a look on a live demo, on a capture that we did with HoloLens. You will recognize that there is maybe a bit more distance than you would expect. This is caused due to the fact that the capturing of the HoloLens just does not show the top of the pen and the hologram on the same level. It's the same effect if you close your eyes and left and right, and you will recognize that your finger is going to the left and right. So if you really try it on your own at our booth, you recognize that it's really more precise than what you can see here. So this is just a very simple demo application where you can create a cube. You can do this really on a table. So it's usually in 3D you don't have a surface on which you can write. But if you use the normal environment, you can definitely have a surface and be more precise. So it's really a mixed reality tool. And this was one of our first demos. Here at the AWE, we show an even more advanced version. But you basically get a feeling of how this feels to interact with a pen. It's really natural, and yeah, we think it's really crazy and nice. So this was just an example, but many of you will just have in mind, okay, how do I use this stuff? And in the end, maybe everyone who has heard the panel yesterday where Tim Marrell mentioned something, they have heard of the thing that most important are the use cases. The technology itself can be as good as hell. If nobody's using it in a scenario, then it's a bit worthless. So at the moment, we try to work with companies together to generate use cases. One of my favorites, for example, is the measurement use case. So many of you might heard of the ThyssenKrupp use case where they have the stairs, are using a marker to track it, and afterwards they create an elevator, for example, for disabled people. Here they use a marker, but it would be even more precise and faster if you just make a point here, make another one here, and there you go. So this is one use case where we think that's very cool to use. Another one is just really if you have a hologram and you would like to grab a really small one. It's usually very difficult if you do it like this, but if you use it with a pen, very simple, and it feels just like normal. Another one is, for example, in the industry, if you want to control a robotic arm. Usually also not possible, but with a pen you can even teach it. And furthermore, because we don't like the expression pen, because when you think about a pen, you only think about drawing, which is obviously possible, but it just does not end there. For us, it's an input device, so you could also just use it as a screwdriver for a training use case. You can use it as any kind, like a scalpel for a healthcare use case. It is flexible, and that's what makes it also very, very nice for the use regarding the use cases. Something about the roadmap. We started the journey of Holo-Stylus mid of last year, because after going to trade shows, we did projects with others, we realized that is an issue. And we were looking for a partner because we had a lot of software background, and we found a university in Austria which supported us here. And we started, and end of last year we showcased our first prototype on a small event in Germany. Then at the moment we are looking really for customers and clients, developers who join our early adopter program, so that we can generate use cases, get feedback in feedback loops, and improve it further, so this really can become the mouse of the future. We try to bring a serious production version on the market next year, so that it can really be used, it has a good pricing, and can be integrated into basically every kind of AR, VR, and MR device. Thank you very much for listening. I would like to really invite you to go to our booth. It's, if you go to the exhibit floor, it's just right on the right next to the Microsoft booth. And yeah, thank you very much, and enjoy the rest of the show. Anybody questions? Oh, sorry. Yeah, go ahead. Yes, we have an IMU inside, so you can, if you grab a hologram. Okay, he mentioned whether we have a 3D device, 6 degrees of. It is a 3D device, so really, if you grab something, there's an IMU inside. You can rotate it. You don't have just something on a 2D surface. You're basically really free, so it has everything basically you need to interact in a 3D world. Excuse me again? Pricing of the dev kit. So at the moment we have an early adopter program where you get support for us. This is 4,000 euros at the moment. The pricing for the final device, it is an industrial device in the beginning. It will be below 1,000 euros definitely. We're thinking about cooperating with partners to also bring out consumer versions. But here we observe also the development of the smart glasses market. And once there is head-mounted display, which is also available for users, for end users, then we hope to be ready also with a consumer version. Okay.
How is it communicating with the actual display?
It is all connected via Bluetooth. So yeah, you don't need anything else, just Bluetooth.
Sensor fusion is happening on the device, or?
It's happening in the head-mounted unit, and yeah. So communication between the devices all via Bluetooth. Okay, then thank you very much, and enjoy the rest of the show. Goodbye.